So now let's go the other direction and consider titration of a weak base with a strong acid. So here's what that curve would look like. You're going to start basic, of course, because you're starting with a weak base. You haven't added any strong acid yet. As you add strong acid, the pH will decrease. Because it is a weak base, you will be forming some of its conjugate as you add the strong acid. And so you'll go through a buffering region again where the curve will be flat, where the pH will be pretty much the same for a region of time. Then the curve will drop again, and you'll get to the equivalence point. At the equivalence point, you've added all of the same amount of moles of strong acid as you had weak base. So all of your weak base is converted to its conjugate acid, and so you should be acidic at the equivalence point, and then the curve goes down. So again, we can think about this in terms of what is happening. In the beginning, it's just a weak base and water problem. But as you add strong acid, you are protonating some of your base and forming its conjugate acid here, and you're going to be in the buffering region. Then at the half equivalence point, you've added enough moles of strong acid to convert half of the weak base to its conjugate. So those are going to be equal to each other, the number of moles of the weak base and the number of moles of its conjugate acid. At the equivalence point, you've converted all of the weak base you started with to its conjugate acid. So it'll be a weak acid and water problem. And then at the end, it's strong acid. So the trick is to recognizing what type of problem you're being asked to do. And a lot of times if people get a question and they just write down, OK, at this point in the titration curve, it's going to be a weak base and water problem. And just writing that down, most of the time, if you get that far, you do the rest of the problem correctly. So just identifying the type, there are only 5, of problems gets you a long way to getting the right answer.